Okay, we are going to start by talking about logic and inductive reasoning. So here, when first talking about this for 2.1, there are two things that we're going to go through. So inductive reasoning and then a conjecture. So inductive reasoning, you are using assumptions or patterns to reach a conclusion, using specific examples to make a general statement. And then a conjecture is a guess or opinion made on incomplete information. So for these patterns right here, we have to fill in the next two and then explain the pattern. So first, I look to see how many we are increasing or decreasing by. So going from 1 to 3, we are adding 2, 3 to 7, we are adding 4, 7 to 13, we are adding 6, 13 to 21, we are adding 8. So if I look at how much we are adding by, it looks like they are all even numbers. So I'm guessing we are going to be adding even numbers. So from 21 to our next term, after 8 would come 10. So 21 plus 10 is 31. And then we would be adding 12 because that is our next even number, so 43. And then to explain it, here we are increasing by successive even numbers. So basically it just says we're taking our even numbers and increasing them that are in a row. So that's what successive means, just like in a row. So 2, 4, 6, 8, 10, 12. Number 2, it looks like this one's kind of tricky. At first I was thinking about corners, and it's not quite that. So this one we can see that these two are being reflected, and then this one is being rotated. And then reflected. So then the next one would be rotated. So my next one here, triangle would be down here in the corner. And then for my next one after that, so this one was rotated. This one would be reflected. It would be up here in the corner. So the pattern on this one, which is hard to see, you would reflect across a diagonal and then rotate the shape 90 degrees clockwise. So that one was a little bit more difficult to see. Number 3, again, let's just see how many we're increasing or decreasing by. So here we are increasing by 0, increasing by 1, 2, 3, and then we go to 5. And I'm looking to see a pattern of how many I'm increasing by. So 0, 1, 2, 2, 3. Oh, this should have been a 1. So plus 1. So 0, 1, 1, 2, 3, 5. This is actually what is called the Fibonacci sequence. So it adds the previous 2 digits. So here you are adding the previous 2 digits. And that's what's called a Fibonacci sequence. So 5, then I have to add 8. So I was adding 5, so I'm adding 8. So that would be 21. And then I look, what's the next two, what's the last two term, which is I just added 8, so then I have to add 13. So that would be 34. So here, as you can see, we're just looking for a pattern and being able to figure out, once you know the pattern, then you can explain the next two terms. So on this one right here, 147, we are subtracting by 3, but then how do I go from 144 to 12? So you can kind of mess around with that a little bit, but actually if you take the square root of 144, you would get 12. And then from 12, if you subtract 3, you'd get 9. So I can see a little bit of a pattern from subtracting 3 to square rooting, then subtracting 3. So I'm guessing I'm going to square root 9, and that would give me 3. And then from there, I'm going to subtract 3 to get 0. So we are going to first subtract 3. And then on the next term, take the square root. Okay, 2 left. So on this first one right here, if I look a couple letters here, try to find the pattern between them to see. If you want to try it, you can pause the video and then I will tell you what the pattern is. So this one is a little difficult. It's actually a really good example, but it is actually the first letter of the counting numbers. So it is the first of counting numbers. And your counting numbers start at 0 and go up. So like 0, 1, 2, 3. So here the O is for 1, 2, 3, 4, 5, 6, 7, 8. So then 9 for 9. And then 10 for 10. And then this next one, A, B, C, D, E, F, G. This one is the alphabet. So then H and I there. Okay, now we're going down to counter example. So it is a specific case for which a conjecture is false. So if I make a statement in saying if it is true or false, and if it is false, you have to provide an example that shows that that statement is false. For example here, the sum of two numbers is always more than the greater number. So they're saying like if I take 2 plus 3, both of those numbers are less than 5, which should be true for a lot of cases, but it is actually false. And since it is false, then I need to show an example where it is false. So if I add -2 plus -3, that equals -5. And -5 is less than -3, which goes against the statement that was made. So the sum of two numbers is always more than the greater number. Again, it goes against that. Another example statement, all prime numbers are odd. That is not true as well. So this is also false. Some examples of prime numbers, the only factor they have are 1 in itself. So some examples of prime numbers are 3, 2 is actually a prime number. So 2, 3, 5, 7, 11, 13, and it keeps going on. So all of these numbers only have factors of 1 in itself, and it is false. And my counterexample for that one would be 2 is prime and even on that.